Welcome to the topic of bearings. Okay, so this is bearings that we are going to be talking about. First of all, there are 4 cardinal points. I'll do it this way, that way. N is for north, S is for south, E is for east, and W is for west. Okay, I'm going to spell out the whole word. So North, east, south, west. You only need to write the first letters to represent it. I'm using pen so that it is much more clearly. Whenever we talk of a bearing, we need to measure from the north going towards your clockwise direction, and it must bear 3 digits. So this angle here would be 0, 9, 0 bearing. So this point is at 90. It is on a bearing of 90 from N. Okay, here we have a 90 degrees. So measured from this point, you're 90 degrees. Cardinal directions, these ones here, are for directions. Okay, they're not showing any motion, they're not moving, in other words. So these are only cardinal directions. So let me put some other points here. You probably have touched this in geography. So here now we start from the north. This point would be northeast. This is not 45, I'm just doing it roughly. Here we have southwest. Okay, notice how I'm labeling. N, north, east, second direction, southwest. So here will be southeast, not east south. Change the color pen. Southeast. Here would be northwest. So we have 8 points there that we are to work with. Okay, so they don't show motion, they show direction. Now let's go where we will be applying this. But before that, let me just recall certain rules. We have seen the sine rule, which is A over sine A equals B over sine B equals C over sine C. We have seen the cosine rule. I'm just going to give you one in general that says A squared is equals to B squared plus C squared minus 2BC cosine A. The angle here is the one out here. Okay, so this one here, primarily we're going to use it whenever you have the 3 sides and you can find the unknown angle, or you may have 2 sides and you can find the angle, you can find the other side. This one here you need to work with whenever you have pairs. Okay, so let's go to our problem. Now in this problem I'm going to be choosing points, and we're going to be using graph paper. So we do it 2 methods. We're going to be doing it by ruler, a protractor, or calculator, and I'm going to be using pen for drawing our lines. I'm going to be using black for labeling, red for labeling, and black for drawing our lines. So the reason why I'm going to be using this, so it is much more clear with the markings. Okay, if you're doing this, you are to use pencil. So let's start. We are going to measure a point. Okay, and let's say we start from this position. This is point A. Okay, A is is just a point at random that I just chose, and you are going to do your angles. So that's point A. I have point B, which is at, let me just bring that much better. Okay, point B, expand this a little bit more. Is it here? Yep, we have it there. Good. So we have point B on a bearing of 40. Say, let's make it 60. Okay, so this point B is on a length from here. Let's say that it is on a length of 5 centimeters. Let's make it a different size. We're gonna give it 80 centimeters. So notice how am I putting my ruler as best as I can, okay, at 80 centimeters. So we draw our line right there, okay. So we have that. Now this is, I'm gonna call this 80 kilometers. Oops, I said labeling is going to be red, so I'm going to keep it red. Sorry about that. Oh, and the red pen is not even working, so we're going to have to keep it with black. So A, this is point B. So B is on a bearing from A of 60 degrees. So I'm going to write it up at the top. Point B is on a bearing of 60 from A. Right? Now we want a point C out here, and this point C is on a bearing, so I'm going to point it here so we can see it. Point C is on a bearing of 120 degrees from B. So point C is on a bearing of 120 from point B. For you to do that, you need to come and you will draw a straight edge. Alright, so draw your straight edge right there. This one here is north also, this one here is north. These two lines, this line and this line, are parallel to each other. Notice how they're on the lines, line. This is not exact, but roughly. And point C is somewhere around here, and that is on a bearing of 120 from B. So you are going to take your protractor and you measure that angle likewise. Okay, so that's slightly off right there, and so that's 120. Notice you will measure from the outside, not the inside, otherwise you may want to stop here, and that's wrong. So measure the outside, that goes 120 right here roughly. Now point C, let's give it a length from point B. So point C is on a length, say let's see what length this would be. So this is roughly we're going to use the ruler on a rough scale. We're going to say that this is 80 kilometers, and point B is on a length of, say, let's give it to 5 to 80 kilometers, 50 kilometers. Okay, so this is point C. Let's see what is it that we have now. There, can capture everything. It should be able to capture everything. All right, so we have point B, which is on a bearing of 60 from A. That 60 is right here, 060 degrees, that one. Point C here is on a bearing of 120 from B. That angle is right here, 120 degrees. Okay, now what is it that we can find out? For right now, we're just looking at the problem and just finding things out about it. I want to know what is the bearing of C from A. So we need to figure out many things. We want to find what is the angle in between here also. We want to find what is the bearing of C of B from C. What is the bearing of A from B? Bearing of B from A is not the same thing as the bearing of A from B. You are in two different positions. Okay, so let's join this point to this point and see what is it that we have. So roughly it is at this position here. Okay, if this was a scale drawing, we could easily take a ruler draw a straight line and we measure the length, but it's not a scale drawing, it's just roughly. Okay, so we join those 2 points. Now let's see, what do we have now? I want to know what is the, I want to write it here, we want to know what's length or distance of AC, or length of C from A or A from C. Okay, that's one of the questions. I want to know the angle by A, B, C. This angle here, I want to know what's that angle. Okay, and I also want to know what is the angle here, which, so I want to know angle ABC, I want to know BAC, I want to know BCA. I want to know those 3 angles there. Okay, once I have that, I could figure out many more things. I could figure what's the bearing of A from C, what's the bearing of A from B. Okay, so afterwards I will want to know what is the bearing of A from B, what is the bearing of B from C, and what's the bearing of A from C. Okay, so let's start. So let's bring back our paper here to do our working. So the length of AC, how do we find that out, this length? Well, do this. The first thing you need to do is draw a rough sketch. This is what you have. You have 80, you have 50, you have a line here, you have a line here. This 60 must equal to this 60. Why? These are alternating angles. Okay, and since they are alternating angles, this 60 must be right here also. We know that this angle here is 180, so we're going to say straight line angle equals 180, which is equals this angle, which is 120. Take away the unknown that we have right here, call that angle X. That gives X equals 180. Take away 120, which is equals to 60 degrees. So this is 60, this is also 60. Okay, so you have those 2 angles there. So now we already know at this point what is angle ABC. We have knocked out angle ABC, so we have that angle already. Now we look for length AC, and can we do that now? Yes, because this angle is equals to 120 degrees. Okay, and so we're going to use cosine rule, and we put this length is B squared minus, now equals A squared plus C squared minus 2AC cosine B. So we put here B squared equals 80 squared plus 50 squared minus 280 times 50 times cosine 120 degrees. So we end up with that. So now take your calculator and start to do your calculation. You may do one large operation if you want, or you may do it piece by piece. Okay, so we can work with this piece here. First of all, we're going to be rounding this up to 4 decimal places at this present time. So we end up with 80 plus 80 squared plus 50 squared. That gives us 8900 minus, we're going to say 2 times 50 times 80. That gives us 8000 here, times cos 120, cos 120 degrees. That is going to give us a negative value. Very important that you put that negative value. Do not disregard that negative if you get a negative value. Okay, so keep that negative there, it's very important. So now you're going to say, now b is equals to the square root of this being operated. A negative times a negative is going to make it a positive, so you put 8,000 times 0.5, and that was going to give us a positive sign, plus 8,900 give us 12,900. So therefore b is equals to the square root of that value, 12900, and that gives us 113.6 kilometers. So we have found the length of AC. So we come here and we put into our values. Okay, length of AC is equals to 113.6 kilometers. So this is 113.6 kilometers. Okay, now this is 120. We could figure out what is this other angle. Notice we want angle ABC, but ABC we already have that, which is 120. So we come back again to our working out, bring the problem a little bit more up, take your paper. So this is A, now we're going to B. So to be clear with the examiner, you can put from A, angle ABC equals 120 degrees. If you're questioning why did I put from A, this is telling the examiner that I did not guess this from the blue sky. I brought this in from the previous part of the problem, which gives us here, okay, 120 degrees. Now we have here 113.6. We can now use sine rule to solve for the other angles. So we're going to put here 50 over sine, which we don't know here, call that angle x, equals this length, which is 113.6 over the sine of 120 degrees. We rearrange this for us to get x. So sine x equals 50 sine 120 over 113.6, and so x is equals to the arc sin of that value. Take your calculator, round off your values to 1 decimal point. 50 times sin 120 equals, divided by 113.6, close bracket, and that gives us 0.3812. I'm rounding it off to 4 decimal places so as to try to be as accurate as possible. Now, because you are doing your work and you may be rounding it off to a different amount of decimal places, it's very important that to stress if you're rounding off anything here. So I'm going to put here 4 dp. X now is equal to the arc sine of the value. So you should put shift sin 0.3812, and that gives us 22.4 degrees. Now notice that is the angle inside here. So I'm going to put here 22.4 degrees. Here I'm going to keep it as whole number, 22 degrees. Alright, because this is a degree. So we now have angle BAC. So ABC was 120, angle BAC is equals to 22 degrees. Round it up to whole numbers instead. Alright, so let's call them all whole numbers, so no decimal point. So now you have this, now you have this, you have this, or in other words, you have these two angles and you have a third one. But you know total angle in a triangle equals 180, which is equals to 120 plus the 22 plus the other unknown, called that y. So let's give this letter y. So we end up with y is equals 180 minus 120 plus 22. 120 plus 22 give me 142 degrees. So y is equals then minus 180 giving us 38 degrees. So this angle is equal to 38 degrees. So let's put it into our diagram. This is 22, this is 38. Okay, just to be rounding off to whole numbers here now. Now once you finish with this, now what else can you do? Well, what was the rest of the other questions? So here we now have BCA is what we need. BCA is equal to 38. So what is the bearing of A from B? Bearing of A from B now. Notice the bearing of A from B is this whole angle here. So for me to get this angle, I'm going to say 120 plus 60 plus 60, which will give us 240 degrees. So the bearing of A from B is equals to 60 plus 60 plus 120, giving us 240 degrees. Okay, and then let me zoom in there a little bit more. There. Now the bearing of B from C, how do we get that? Well, if this is 120 degrees, what we want is the bearing of B from C. So bearing of B from C will be whole of this angle. This angle is equals to 120, so must this angle equal 120. So we have 180 plus 120, and that will give us the bearing of B from C. So the bearing of B from C is equals the 120 plus the 180, and that gives us 0, 10, 300 degrees. Okay, and then the bearing of A from C. Now notice here, this angle here is equals to 88 degrees. This angle here is equals to 88 degrees. So in other words, the bearing of C from A is 88. Bearing of C, okay, so bearing of C from A is equals to 60 plus 22, which gives us 088 degrees. That is 88 degrees. So the bearing of C from A is 88 degrees. The bearing of A from C now, if this is 88, so is this. Okay, so if this angle here is 88, we can say that this angle here is 88. So we have 88 plus 180, which will be the bearing of A from C. So we come back here, the bearing of A from C is going to be 88 plus 180, 268 degrees. And now we have the bearing of B from C. Bearing of B from C is equals to 300 degrees. Okay, bearing of B from C is 300 degrees. So we have the bearings from everywhere we want. So you have to take the problem piece by piece and see which ones do you have, which ones you need to figure out. Okay, that's all for this topic here. But you need to be careful when they say the bearing of a point from another point. Okay, so this is where bearing becomes very, very interesting. So make sure you look at this carefully. Look at calculations. Look what we use. We use cosine rule, then sine rule. Okay, we did not use sin, cos, and tan, not the trig ratios. We use the cosine and the sine rule.